Good day, guys. My name is Babatunde Oluwatosin Ademola. Today we'll be working on example on Riemann sum. Now we are given a partition on the closed interval 0 to 5. So if you are to write this now, let's have this simple graph here. Let's okay. Let our starting point, which is x0. I give here x1, here x2, here x3, here x4. Now look at this one. We are starting from 0. 0, because if you look at this, 0 to 2, then 2 is less than 3, true, is less than 4, than 5. So our n here is equals to 4. Now what we got? And we are given a function. The function given to us is 25 minus x squared. So here my delta x1 is equals to x1 minus x0, which is equals to 2 minus 0. Delta x2 is equals to x2 minus x1, which is equals to 3 minus 2, which is equals to 1. So delta x3 is equals to x3 minus x2, which is equals to 4 minus 3 is equals to 1. So delta x4 is equals to x4 minus x3, which is equals to 5 minus 4, which is equals to 1. Now, by definition, we have mi to be equals to supremum acting on this, which is less than or equals to x, like this. So what's going to happen is, by the time we put I to be 1, the supremum between the boundaries, that's what we are going to use to look for our, that's what we are going to put as our x. So we'll be doing that now. While the small m is the infimum f of x, xi minus 1, that's equals to x, that's equals to xi, then I equals to 1, 2, up to n. Hope you grab it. So when I equals to 1, so we are going to have m1, then supremum f of x. When it is 1, we are going to have 1 minus 1. When I equals to 1 minus 1, we are going to have x0 less than equals to x, less than equals to x1. You got? So we are going to have supremum f of x. Now x0 is what? 0, less or equals to x, less or equals to 2. So the supremum within the range of 0 to 2. I explained something in the last video talking about maximum and minimum. If the max of this thing is 2, it is a closed interval. Definitely our supremum is also what? 2. So here we're working on what? The 2. So it will be function acting on the supremum on this boundary. So our small m will be infimum f of x, x0 less or equals to x, less or equals to x1. So this one will be infimum f of x acting on 0, x2, which is equals to f of 0. So when I equals to 2, we are going to have m2 equals sup f of x. It is 2. This one will be x1 less or equals to x, less or equals to x2. Because it is 2. Look, if you come and put 2 here, right? 2 minus 1, you are going to have 1, then you have your 2. So equals to supremum f of x such that now x1 is what? From here, x1 is what? X1 is 2. So you have 2 less or equals to x, and x2 is what? From there, 3. So less or equals to 3. So this is going to act on 3 because 3 is our supremum there. Then we have m2, which is equals to infimum f of x, x1 less or equals to x1 less or equals to x2 equals to infimum f of x to be 2 x 3. Now our infimum here is what? 2. So this is going to act on f of 2. So when I equals to 3, we are going to have m3 equals to supremum f of x such that we are going to have x2 here less or equals to x less or equals to x3. Then the supremum f of x. Hope you grab it. So x2 here is now 3 and our x3 here is 4. So the supremum between 3 and 4, if you have this kind of stuff now, 3, 4. So what will be the supremum of this interval? It will be 4. So our function is going to act on the supremum. So m3 is infimum f of x. So x2 like this, x3. So you are going to have infimum. So you have f of x such that 3 less or equals to x less or equals to 4. So this is going to act on the infimum. So the infimum between this range is 3. So it's going to act on it. So we are going to have f3. So that will be a function of f3. Now lastly, when I is equals to 4, capital M4 is equals to supremum f of x. We have, when it is 4 now, it will be 4 minus 1. So we have x3 less or equals to x less or equals to x4. So supremum f of x. So x3 is 4 and our x4 is 5. So the supremum is acting on 5. The function will act on 5, which is the supremum. So while mi is equals to infimum f of x, now x3 less or equals to x less or equals to x4, and that which is equals to infimum of function such that it's going to act on 4 less or equals to x less or equals to 5, which is equals to f of 4. Now recall that we are given a function here. This is our function. So given this function and given f of x to be equals to 25 minus x squared. Now just note that we are given this. Now by definition, if you can recall very well, that our upper Riemann sum up of f, our upper Riemann sum is summation I equals to 1 to n mi delta xi. That is, I know our n is 4 because we can't start from 0. So we are 0, 1, 2, 3, 4. So our n is 4 because looking for forward difference of x naught is not possible. So we are going to start, our n will be 4 because of our forward difference. Now this will be I equals to 1 to 4. So mi delta xi. So this, I can write this as m1 delta x1 plus m2 delta x2 plus m3 delta x3 now plus m4 delta x4. Now let's have this. Now our m1 here is f of 2, so function of 2. Now our delta x1 from here, look at where I'm defining it. Our delta x1 is equals to 2. So that will be times 2. So now let me write this expression. F of 2 dot 2. Now plus our M2. Our M2, look at it. This is our M2, which is what? F of 3. F of 3. Our delta x2 is 1. So times 1 plus our M3. Now from here we look for M3. M3 is F of 4. F of 4. Abi? Now delta x3 is 1. Now plus M4. What is M4? F of 5. Abi? Our delta x4 is what? 1. So yeah, and recall, I said we should take note of this. The function given. F of 2 will be 25 minus 2 square. Everything times 2. Then plus F of 3 will be 25 minus 3 square. Then plus F of 4 will be 25 minus 4 square. Then plus 25 minus 5 square. This one will be 21 into bracket 2 plus this one will be 25 minus 9, which is 16. Then plus 25 minus 16, which is 9. Then plus 0. This will be 42 plus 16 plus 9. This is going to give us 67. That's the upper Riemann sum. Now, that's the upper Riemann sum. Now, for the lower Riemann sum which is LPF, same method, which is equal to summation I equals to 1 to n small m delta xi. For same reason, our n is equals to 4. This is mi delta xi. And this, we can also say this is m1 delta x1 plus small m delta x2 plus m3 delta x3 plus m4 delta x4. Now equals to, now our small m, if you come here, our small m1 is f of 0, and our delta x1 here is 2. So dot 2. Now plus dot 2 plus, now m2 here is f of 2 dot our delta x2 is 1 plus m3 here, small m3 is f of 3. So we are going to write f of 3. Our delta x3 here is 1. So we are going to write dot 1 plus m4, small m4. Look at small m4. Small m4 is f of 4. F of 4. Delta x4 here. Delta x4 here is 1. So dot 1. So yeah, from the function given to us, 25 minus x squared. So f of 0 will be 25 minus 0 square into bracket 2 plus this we are going to have this is going to be 25 minus 2 square like this. Now plus 25 minus 3 square. Now plus 25 minus 4 square. Now this goes to 2 into bracket 25 plus 25 minus 4 like this. Now plus 25 minus 9 plus 25 minus 16. Now this is going to give me 50 equals to plus 50 plus this one is going to give me 21 plus this is going to give me 16 plus this is going to give me 9. So adding this is going to give me 71 plus 25, 25, that will give me 96. So that's our lower Riemann sum. These are you go